With the James Webb Telescope readying to change our perspective of the universe, it is a good time to look back at the Hubble Space Telescope, who has been doing exactly that since its launch back in 1990. Before we put a telescope into space, we were absolutely limited in our observations due to the Earth's atmosphere. The protective air that surrounds our blue pearl hinders Earth-based telescopes by reducing the resolution as it filters out some of the light before it hits the mirrors in the telescope. In addition to that, our atmosphere filters out almost all of the X-rays coming from space, and a good thing, and thus it makes it impossible to view the X-ray spectrum from Earth. With space telescopes, we have taken the next step. We have sharpened our resolution as well as opened up the X-ray spectrum. We opened the door for Hubble and future space-based telescopes to dazzle us with clarity through an open window into space and time, into our universe. In today's video, we are going to look at 5 super cool discoveries made by the Hubble telescope. In addition to that, if you stick around until the end of the video, I'm going to tell you why the James Webb telescope is going to take this to yet another level. So without any further ado, let's start with number 5. From as early as 1963, there were radio observations of an unusual star with a very puzzling spectrum. Something was off, but no one was yet ready to figure out what exactly that something was. By 1970, more observations had begun to show velocity dispersions of stars in the center of elliptical galaxies. Those are the round ones. Within a year, the first hypothesis that we could have a massive black hole at the center of the Milky Way was made. By 1974, Sagittarius A, a radio source, was discovered at the center of the Milky Way. Spoiler alert, that just may be a black hole. The Hubble Space Telescope had the resolution to allow scientists to take much better measurements of those galactic cores. With better measurements, we had a good idea just how fast things were moving around these objects. With a known mass and the velocity of those masses, we could then work out the mass of those black holes. And guess what? They were massive. Supermassive. These new observations of galaxies show that the larger the galaxy and the stars clustering around the center, the larger the supermassive black hole. This suggests the black hole grows with the galaxy. Holy, that is pretty darn cool. Before Hubble, so before 1990, the only planets we knew of were those 9 planets in our own solar system. Hold up, I know Pluto was demoted in 2006, but in 1990, we still considered Pluto as a planet and not a dwarf planet. Just to be clear, it is a dwarf planet, but I'm just sort of saying 9 because, well, in 1990 we thought it was 9. Wow. Ramble alert! Finding a planet outside of our solar system around another star was going to be a big thing. If we go back a little further to 1983, there was a disk of material spotted around Beta Pictorius, which looked like it had the raw materials for planet formation. And that certainly provided us with hope that we would eventually find planets way out there. Hubble was certainly not going to disappoint us. In 1992, the first 2 rocky planets outside of our solar system were found, orbiting PSR B1. A year later, we found a massive 2.5 times larger than Jupiter gas giant, 1,170 light years from Earth. That is completely awesome. Hubble was providing the resolution for us to see a dimming in a star's light as a planet transits before the star and us. Since these initial planets, with the help of Hubble, we have now found over 4,000 planets outside of our solar system. The formation of planets around stars has been observed to be more common than we expected, and this is way cool. In 1929, Edwin Hubble, yes, the telescope is named after him, published a paper about the expansion of the universe, and his paper would have lasting impacts on our understanding of the universe. Hubble's law predicted a constant expansion of the universe, which would show us that more distant galaxies would be moving away from us faster than the closer ones, and that is what was actually observed. This rate of expansion was expressed as a constant, the Hubble constant. Well, along came the Hubble Space Telescope, and it discovered that the universe was actually expanding faster than it should be. In fact, it was moving 5 to 9% faster. This is one of the biggest puzzles today because we do not know for sure why this is happening. There are different hypotheses out there about exotic particles and dark energy, but they currently are not perfect fits for the data. Much more research is needed, and in the end, figuring out this gift from the telescope will lead to more discoveries and broadening our understanding. That is totally cool. Before Hubble, it was commonly thought that the universe was between 7 and 20 billion years old. Wow! Most of this was based on Hubble's law and the Hubble constant, which provided a rather large standard deviation based on the quality of the observations possible. They used Cepheid variable stars to help them calculate the constant of expansion, and then tracking that expansion backward would estimate the age going all the way back to the Big Bang. The Hubble telescope, with its much better resolution, would measure Cepheid variable stars and their change in brightness over time much more accurately. Now, if you're asking what a Cepheid variable star is, think of a pulsar. Using the Hubble telescope information, the age of the universe was narrowed down to between 9 and 14 billion years. Whew, that's still a large range, but they were able to really narrow that down with additional background radiation information provided by the Wilkinson Microwave Anisotropy Probe, or WMAP. The new age of the universe turned out to be 13.7 billion years, plus or minus 200 million years. That is now absolutely cool. Last but not least on our list, the Hubble telescope has found the furthest star ever. And we're talking about a star that is 12.9 billion light years away. Keep in mind, when we are looking at stars, we are also looking back in time. So that means the light we are seeing from this star began its journey 900 million years ago after the Big Bang. Pretty neat, and we don't even need a DeLorean. The previous record holder was a star that was 9 billion light years away, and yeah, Hubble discovered that as well back in 2018. Amazingly, this was just announced by NASA, just as the excitement for the James Webb Telescope is building. And without a doubt, the James Webb will be looking at this star and perhaps even something beyond that. This is super cool, as the further we can peer back into time and glimpse the understanding of the past, the more we can understand the future and the nature of this universe we live in. The Hubble telescope is not retiring quite yet, but another telescope is coming online, and that is the James Webb Telescope. This new telescope will conduct most of its observations in infrared, which will give it the ability to see through dust, clouds, and other distortions that could be troubling for Hubble. It will be able to see things more distant than Hubble, and thus we will see further into the past than we have ever seen before. We will hopefully be able to see some of the first stars and galaxies. In addition to that, this new telescope will be better at determining the sort of atmosphere an exoplanet has. This could be very exciting in the search for life out there. We will definitely be talking more about the James Webb Space Telescope in a future video. If you like this video, be sure to hit like and subscribe for more science content. I will be back at you again next week when we can get our science on for a new video.